All right. Before we start, let me review what we have done here. We already have at least a glimpse of a limit concept and how we are going to use a limit, okay, in terms of definition intuitively. Okay, so we have this kind of definition. We call this definition is intuitive definition. Okay, because to prove the concept, we need to have a really exact and really bold definition on how the thing is going on. Because in math, if you need to prove something, you need to prove exactly what it is. Okay, but by intuitions, intuitive means you can say that this means, like, if you see this graph here, our minds say that if we are moving from the left and we are moving from the right here, it will goes into some a number, right? A number here. We call the number here as an L, okay, which is a real number. Okay. Of course, in limit, like I said previously in the course, that probably the A itself, when you put into functions, like probably here, like f of A, it can be undefined. It can be defined also as a number. It doesn't matter. In limit, they both has a number that is L. Okay, I will go through some maybe examples and more elaborations on what limit is. Okay, so okay, let's start the courses. Okay, here I have 3 different graphs. Actually, it's the same graph with some exceptions at number A. Okay, if you look here, we are just looking at a really smooth graph without any problem, without any defect. Okay, without any, we call any discontinue. So it is discontinue all the way around here, right? And then the other one here, we are going through here, and we see here there is some hole. Okay? There is a hole. But again, okay, maybe in your high school, or maybe in your textbook, if you already have the textbook, your textbook also picture the graph like this. There is a hole. But remember, if you draw the graph in a real life using some software, some computational calculator, this will not be shown, okay? Because the hole is actually just only a dot, like let me make it smaller. Yeah, maybe a dot like this. Like if you are in a pixel, maybe it's just 1 pixel. Okay? But to see whether it's a discontinuity in this graph, some textbook, they will mention, okay, you need to make it like an open hole. So we know that at this point here, at x equal a, it's undefined. So at fa, it's undefined. Okay. And we also can see from here, actually, fa, it has some maybe b. Okay, maybe this is b, or this b, probably. But these three graphs, they are showing the same results or same conclusions. That is limit as x approaching a of some function f here. They will all be going into the same conclusion L. Okay, same conclusion L here, and here. 3 graph, same conclusions. Okay. All right. So even though you have undefined at exactly A, or maybe different conclusion with this, the third one, but in limit, they are the same results. Okay, they are the same results. Okay. All right. Before we are move on into the course, let me remind you. Please apply Google account. Okay, Google account. Google education account. Okay, Google education account. You just need to fill in your, I think, just your student ID. So you will get a new new email. So your student ID at, and then this will be a geapps.ntust.edu.tw. This will be your new Google education email. Okay. So why you need to have this? Because firstly, I will use this Google account to register to the Google Classroom. Okay, so you need the Google account to register to Google Classroom. Okay, I will share later when we finish the course and we finish the recording, and I will announce in the Moodle. Okay, so this, yes, of course. I think you can apply online. I already give you the link. I will give you the link again in the announcement. Okay, so please wait. I think several of you already apply. And you already have your Google education account, right? I think some of you, because how do I know that you already apply? When you go into this Google Meet link, you don't need my permission. So, for example, if you are not using this GApps and TUST, you need to wait, right? You need to wait whether I give you permission or not. But if you're using directly the Google account, you will go in directly, and you will not, especially me, okay, I will not distracted, okay, because sometimes you just come in and then there will be a notification sound, and then there will be a pop-up. When I was in the middle of teaching, it is really a bit annoying and disturbing. So that's why we need to have this Google account, so that we can have a good environment for learning. Okay, and the important thing is, because I will use this Google Classroom to have some probably assignment, but I will not give you assignment until maybe next 1 or 2 weeks. Okay, and then also good for preparation for quiz. Okay, so probably 2 or 3 weeks from now we will have a quiz. Okay, a quiz. And the second is actually for not for so that less annoying or less disturbance. Let's say less disturbance. Less disturbance for the course or for the class. Okay. I will give you the link again. It's actually in Chinese, but so for international students, I think you can just use the Google Translate. Yes, I think that is the link, so you can check that out. Okay, if you want to apply, right? If you are the international student, I think you can just translate the article, and I think it's not that complicated, the process. I think in a few hours or maybe one day you will just use your student ID, and then you will get your new Google Education email, or GApps email. Okay, so that's the Google account. Okay, all right. Okay, okay, let me continue. So basically, limit. All right, and one more thing. If I'm giving you this, okay, I'm not sure whether you have learned in high school or before. If you have limit as x approaching 0, and you have your functions sine x over x, can you guess what will it be? Yes, how you get 1? Yeah, it's through this 1, but how you can get this? Ah, really good, really good, really good. Okay, yeah, that's correct. Okay, but sometimes, okay, and this is what you should not do. Okay, let me give the example. Somewhere around the limit concept, you will somehow will be learning about the L'Hopital's rule. Okay, and from this L'Hopital rule, it said that if you have a 0 over 0 situation, you can derive the top and bottom. So derive. I will not explain in detail. I will tell you this is a little bit later, but I will just show you a little bit what I mean in this explanations. Okay. So what you need to do in L'Hopital rule is, if you see any 0 over 0 situations, you need to derive a functions on the top and derive the functions on the bottom. And you see here is precisely 0 over 0. Right? And then maybe your mind telling you that, okay, this is 0 over 0, and then we can use L'Hopital rule. So use L'Hopital rule. Usually you make this LH, and then you write down a limit, and you derive sine x become cos x, and x become 1. Okay, and then lastly you put 0 here, and you get cosine 0, or you can make it 1. Okay, same answer. Same answer. Correct, right? But in process, this is not okay. This is not okay. This is wrong. Okay. Do you know what's wrong with this one? Why this is wrong? Why this is wrong? Anyone know? Okay. Okay, let me tell you. The reason is because this is something called, we say this is a circular reasoning. You will know why later if we going into maybe more in derivative parts. Okay, so the reason is, if you look here, this is pretty much a definitions. Okay, in terms of math, this is pretty much a definitions. Okay, when you look for the L'Hopital rules, you want to derive each part, right? Each part here and each part here, and you will be in trouble when you define this part here. So the question is, can you prove that this result is cosine x? The proof itself, it will require these definitions. So that's why it's circular reasoning. So you cannot use this as your proof. So that's why this L'Hopital becomes irrelevant. It's not relevant at all. Okay, you need to use another theorem to prove that this is true. Okay, and one of the students say that the Squeeze theorem, yes, that's a method to make these definitions true. But I will maybe tell you the Squeeze theorem maybe next week. But now I'm just telling you, you have this do not use any Lopital rule. If you know the Lopital rule, you do not use Lopital rule. Okay, you need to know how to use Lopital rule properly. Okay, all right. Now we have this, but I will not going into detail here. Maybe any questions for now? If you still confuse this, don't worry. I will go back later. Okay, later on. Okay. All right. So please, you need to avoid this circular reasoning. Okay. So let me. Okay. So this is a no-no. Okay. Okay. Avoid this. Please avoid this. Okay. Okay. Let's move on. Let's move on to one-side limit. One-side limit. Here is the example. It's the Heaviside function. Let me draw the function first. It's actually not really that complex function. This is just showing you the what function is. This is 1. This is y and x and 0. But this 0, it has maybe just use this. It has and it also has okay. So the function is from 0 to that way to the left to the negative infinity, and the function here is going from 0 to some infinity positive there. Okay, so we call this Heaviside function, or we can write in piecewise. Okay, so basically this function is from the it's electrical current used for, actually it's the name is from the person electrical engineer, and it used for to describe electrical current. So you have switch switch at time t. So when you switch the electrical current at time t, or t equals 0, so precisely here at t equals 0, there's no single number that the functions approach as t approach 0. So in this case, if you approach from here and approach from here, if you're thinking the limit concept, there will be no limit here. So there will be the limit. You can write D and E. Limit doesn't exist. So sometimes if you read any D and E in the limit concept, it means that the limit is not exist. Okay. So if you write down here in terms of limit, so as t approaching 0 from the left, you write the negative in the power function h, and this will be 0, right? So we are moving from the left to 0, and it will reach approaching 0, right? We'll reach close to 0. And when limit as t approach 0 from the right side, from the positive side, the function will be equal 1. And this is what we call, this is one-sided limit. Okay? So one-sided limit is we approach the limit from one side only. Okay, so approach limit only Okay. Okay, let me write for you the definition. Okay. Okay. Okay, I will maybe write here. So limit Sx approaching some number a from the left. Let me write just L, and then limit Sx approaching a from the right. Let me write the same L. Okay, so we call this as left hand limit, right hand limit. So this means x approaching a from the left, and this is the same a from the right. Okay. Okay, I think it's easy to comprehend, right? To understand, and then by the conclusion. Okay, by the conclusion. By conclusions, the limit Sx approaching a, because from the left, from the and from the right, it has the same L, then this is true. Then this is true. Okay. True when, okay, when, okay, write again what we are doing before, that this is the same as the left hand limit, the same as the right hand limit, which is L, and that's why there is a limit exists. Okay, so there true or exists. Okay, exists. Okay, and I think this is important concept for you. This part here. Okay. Okay, any questions first? Any questions first? Any questions? No? I think it's easy to understand, right? The left hand limit and right hand limit. Okay, so every time you have a limit, and you can imagine the graph, you can see, is there any anything that weird or anything that happened in some x equal some number. You can check whether it is approaching the same number or approaching a different results. Okay, let me give you the example here. Okay, see here, I'm having the function g. Okay, the function g. If you look at function g and look at the questions, we are approaching the at least two case, 2 and 5. So let's look 2 and 5 here. The first case, we are approaching 2. Okay, we are approaching 2 from the left. We are approaching 2 from the right. When we are approaching 2 from the left, that's the first question here. It's resulting, yeah, it's 3, right? And when you look for this one here, it's 1. So approaching 2 from the right, the limit will be resulting in 1, right? So the conclusions, because it has 2 different answers, then we can write DNE. Okay, so limit doesn't exist. All right. Now we are looking here the number 5 now. Let me use different color. Let me use green one. Okay. From the right, from the left. Okay. It is around. It's around 2. Let's say it's equal to. Okay. Let's say it's equal to. So this will be 2. This also 2. So the limit is 2. As x approaching 5 for the function g is also 2. Although g equal 5 is not 2. Despite the fact that still the limit is 2. If you see from here, when you plug in 5 here, it's not 2, right? Let's say it's 1. Okay, let's say it's 1. Okay. So you still get your limit result. Okay. Okay, I think quite easy, right? And I hope you don't get you don't mind for all of this easy, simple introduction. Okay. Okay, so the next one is if you have sine pi over x, what will you have? So it's a little bit different from before. The previous one, although I haven't explained clearly what this is. It is sine x over x. Now, sine, but we have pi over x. Okay, so sine pi over x. Okay. If we look at what the limit is, it's approaching 0, right? It's approaching 0. So at x, so x, it couldn't be 0, or x is undefined at 0. Okay, so what can we do? So let's say we tried several x. Okay, let's try several x. Let's try x equal 1. So we have sine pi. It's 0, right? And maybe because I think it's quite good equation here. Let's say pi over something decimals, maybe half, 1/3, maybe 1/3, and you will have sine 3 pi. Again, it's 0, and you get more and more 0. And maybe you have a lot of example here that mentioning 0. And maybe we are conclude that this limit is 0. Probably. Do you agree? All right. Yeah. You disagree? Yeah. Okay. Good. Now, we are thinking about functions, right? We are thinking about trigonometric functions. Okay. So we are thinking about the sine function, which is we can see the curve that is the maximum number or the maximum result for any sine or any cosine is +1, and then the minimum one is the -1, right? It's always going up and down all over the time. And let me go through the Geogebra. We can use that to see clearly what is happening. Because if I draw a little bit difficult, and you will not see the what I mean. Okay. Okay, now this is GeoGebra. Now I will have sine, let's say pi over x. Okay, now we have this kind of graph. Okay? If you look this, it's pretty much when it's going into 0 from the right and from the left, you will see that it has, the curve has increased and decreased all over the time, right? If you look in the middle there, yeah. You see here, it's really, really messy, right? So the conclusion is it still doesn't have any exact value for the limit, right? Because it's going to be increased and it's going down, it's going up, it's going down, right? Okay, well, let's back to our notes. So still, it doesn't have any limit. So the limit doesn't exist. It is wrong. So this limit doesn't exist. So it has, if you see the graph, it's +1 and -1, and it's all over the place in the middle when you going from the right or from the left. Okay. So to approach the limit, if you can draw visually, and maybe you can imagine how it looks, I think that also one way to guess or to assume the value. Okay. 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 What else do we have? All right. The other important section, this limit. Actually, you can try by yourself to draw. Maybe if you're using any graph calculator, maybe in your computer, you can use Geogebra, or another one that I'm also using sometimes is Desmos, but mostly I'm using the Geogebra. Yeah, more or less, this is the graph. Okay. So let's say this is the function. Okay. Now, if you look here, what is happening now is when you try to approach the number 0 from the right, from the left, it's following the curve, right? Following the curve, and it's going up and up and up, and you will never know when you are reaching the finish line, right? And from the left, also the same. It's going somewhere beyond calculations, right? And we can write here as x closer to 0, x squared also closer to 0, and 1 over x squared becomes very large. Yeah, you can, if you like, you need to make some convincing statement. you can try some x. Try from 1 and try from plus minus. And then try more and more smaller number, and try more and more smaller number. You can put like a lot of 0 for the decimals, and you will see that the results for the x1 over x squared will be very, very large as x 0. Okay. Right. Now we can write this case. Okay. We can write the notations infinite like that. Okay. But okay, you need to remember this is quite important. This is not a number. Okay, this is not a number. And this doesn't mean the limit exists. Okay. So we are taking the infinite as symbols to indicate that value of the function tend to become larger and larger. Or you can also say the value is or increase without bound as x closer to some value a to a. Or you can write the official definition here, and this will be the definition here. Okay. Okay. So increase without bound means that it will always increasing, and you don't know how to stop the number. Okay. It has no restriction, and it will going up, okay, eventually. So again, let me repeat one more time that infinity is not a number. It's a concept. It's beyond calculation. So you never count, or it's impossible to count infinity. Okay. All right. The next one is okay. It can be positive, the infinity. It can be negative. Okay, it depends on how the function is, right? Okay. So let me repeat, and let me draw for you the illustration for what we have previously learned. This is just a random graph. Okay. Now let's say this is A, and we have y equal fx, f of x. So we say that limit as x approaching 0, or as x approaching a, some number a, of our function here, it will have the infinity. So again, this means that f of x increases without bound as x approaching a. And we can also have when we have the infinity going to the opposite sides, right? The negative infinity. It will be negatively larger, larger and larger. Okay. Okay, do you need the official definitions? Let f be a function defined on both sides of a, except possibly a itself. Then it's actually going to here the limit here, and this means that, or maybe I will put this into the first. Let me make it here. Make it here. Okay. So the limit is becomes infinity, and this means values of the function can be made arbitrarily large as we please. By taking x sufficiently close to a but not equal a. Okay, this is actually the official definition, and you don't really need to memorize all of this. And if you are maybe difficult to understand some English terms, because I think some terms, even for international students or maybe any foreigners that read this one, maybe they also not really understand at the first time they read. Okay, but if you look at the graph, and you can imagine that you have a defined function, the left, right, and you approach some number a from the left, from the right, and it goes beyond this line here, and it goes larger and larger and larger. That means it's going to be infinity. Okay, I think that's more clear rather than you read all this, right? Okay, this is just to show you what the exact official definition is if you want to write in a paper. Okay. All right. Okay. The same thing happened for this one here, for the negative infinity. And you can just change that. It's not just larger, but negatively larger. Okay, negatively larger and larger. Okay. And the other important point here is, you notice that when you are approaching a, you'll have this line. It's called the asymptote, right? I think you know this one. You know this asymptote. So you will have a vertical asymptote. Okay, now to have this asymptote, at least, okay, to have let me write a vertical line is called vertical asymptote of curve y equal a function of x. If at least following statement uh, one of the following, sorry. Okay, so first, let me go up a little bit. All right. So first is limit. And also the negative infinite. Okay. Okay. Now, okay, let me give you another example here for the vertical asymptote. So basically, as long as you have one of these, you can say that, okay, we have a vertical line, x equals some number, and it is the asymptote. Okay. Okay, let me go through one example. Okay, the question is just, does the function have a vertical asymptote? Of course, the answer will be yes, right? But if you look at the the graph, this is I think also important. Let me stop this for a while, and we'll look at the GeoGebra one more time. Let me turn off this functions and let me write another one. Okay. Let me write 2x over x minus 3. So the red color one will be our function. So we have this kind of functions here. And of course, at x equal 3, there will be a line, right? Let me write the x equal 3. Okay, that will be the asymptote, right? Right. Okay. So from the right, it will go through positive infinity. From the left, it's going down, negative infinity. Let me take this as a picture first and copy to our lecture. Okay, wait. Okay, wait. Well, let me draw that first. Okay, so if you see this graph here, what do you think about the limit? Is there any limit? Yes. Okay, good. Okay, let me go back to our notes. Yes. Okay, so here, you'll get the, here, maybe this is x equal 3. Yeah, probably like that. Okay. If you look here, from the right side, it's going to be as x approach 3 from right side, it's going to have positive infinity, right? And as x approach 3 from left, it's going to have the negative infinity. And because of this, it's not the same as limit it doesn't exist. Okay, the limit doesn't exist, but it has the asymptote. Okay, because it has this, and it has this. But because it's not the same conclusions, then the limit doesn't exist. Okay. So you say it doesn't exist because it's going to be infinity or negative infinity. It's because the right and left hand limit not the same conclusion. Okay. Okay. All right. Yeah, we can move on, I think. So because the question is, does the function have a vertical asymptote? Because you write this, then you can simply just say that x equal 3 is the vertical asymptote. It's vertical asymptote. Okay. Or you can write this also if both of them are okay. You only write one is also fine because you already make conclusion from here is also vertical asymptote. Okay. All right. Okay. Anything to discuss or no? I think it's pretty much easy, right? Not really that difficult. Okay. So we'll start like really slow here in limit. Probably in 2 or 3 weeks we will move faster, and I will skip some parts in chapter 2. The precise definition of limit, I will skip that for now. I will try my best to record additional lectures so that you can view besides from these live lectures. Okay. And by the way, I think you have heard from the official announcement. I'm not sure the students already get or not, but now the classroom in our university is ready. But for our class, because our class is quite a lot of students, quite a big class, right? We have around 40 to 50 students, and the with the social distancing in the classroom, we are unable to have the class. Okay, so we will still have the online lectures this semester, online lectures until the end of semester. But for the final exam, we can apply a classroom. So probably we will meet all students. I will meet all the students when we have the exam. Okay, when we have the exam. But please wait for the official announcement, or if is I think in this week there will be the announcement. There will be an announcement. So yeah, we will still have this kind of lectures, online lectures, and I will add more video, additional video, okay, to help you understand. Okay. So I will just move on, and I think most of you already learned all of this in high school. Okay, okay, so let's move on. The next part is the limit law. Okay, limit law. It's not O, it's A. Okay. Now let me write all the statements, and I think it's pretty much intuitively easy to understand. Okay, so let me just write them. Suppose C is a constant, and limit so both of them, both limit exist. Then, so this is the important thing here. So you need to know first that both limit exist, and you can do all this simplification or all of this law. Okay. So then, first you can make this the sum plus and also the difference. Okay, so I will write the difference. Just write negative parts here. Meaning it's not plus minus, but it means in my notes you have the sum and you have also the difference. Okay, you can because it works simultaneously correct. Okay, both are correct. So the second one, you have a constant, and you can factorize the constant outside of the limit. I think this is also it's easy to understand the concept here. And if you have the multiplication, you can separate this. Okay. And you have and this should be true when if limit x should not be equal to 0, right? And I think this limit law, it's easy to understand, and it's also useful, okay? Especially when you are dealing with some proof concept or some formula, it is quite useful. Okay, I think I will go a little bit faster now. Yeah. Okay, let's move on, and let's look up this picture now. We have two functions, f and g, from this picture. The red line is the red curve is the f, and the blue line is the g. The blue curve is g. Okay. Now we have all these questions here. First questions is limit as x approaching -2. Let me write here clearly. It's -2. Okay. And it's f of x plus 5 g of x. And the second one, limit as x approaching 1 from the f of x multiplied with g of x. Okay. And the last one is limit as x approaching 2 for f of x over g of x. Okay. So the number is -2, 1, and 2. Okay. So -2 here, 1, and 2. Okay. Okay. Now, if you see the first case here, we approach f. Okay. First, we approach f from the left and from the right, and it goes into 1, right? Let me write here, maybe here. So limit as x approaching -2 of f of x is, from the graph, we say that it's equal 1. Okay. And for g, it's here, right? It's equal -1. Okay. So for g, it's -1. And we can calculate 1 plus, this is 5 and -1. So we will get -4. Okay. I think it's pretty much straightforward. Okay. But the second one, what will happen here, x approaching 1. So from here, I think for f, it's fine. No, not a problem. It's equal to. But for g, if you see here, you have a different answer. So let me write here, limit x approaching 1 for gx. Okay, it doesn't exist. So we cannot use this. Okay. All right. Okay. Okay. The last one. Limit as x approaching 2. Okay. For f of x divided by g of x. Approaching 2 is here. So it's around here, going here. Okay. Well, it's not there. Sorry. It's not 2. Why I'm looking here? Should be here, right? Okay, so it's this one. Oh, sorry. Okay. So the first one is here. Not a problem for f. For g has a problem. What is its problem? The problem is when you approach 2 for gx, it's 0. Okay, and this case is it should not have been a 0, so it's also doesn't exist. So this doesn't exist. This also doesn't exist. Okay. So first, before you are going through all the limit law, or you want to separate the limit for the multiplication or the division, you want to separate the limit, you need to make sure first the limit exists, and secondly, for this one, you need to make sure that it's not equal 0. Okay. So that's the limit law, and I think I can move to. Okay, and the other part here, for the limit law, aside from what we have done for plus, minus, multiplication, division, there are also the exponent, the power law. So if you have limit, you can write this whole limit inside, and then power of n. And where n is a positive integer. And limit this is also the same. They don't need to be positive integer. Why I'm not writing the negative integer? Because if I write in the negative 1, it will be going back and forward this too long. Okay, but I think you guys get my point here. Okay, right? And if you have the limit x approaching a for a constant, it's still a constant, not really a big deal, right? And limit x approaching a for x is equal a. And then also we have the limit because of what we have done here. Let me write here. It's the power law and the root law. And this will be the implication here. Okay. And positive integer. Okay, from here, if we look at let's say limit x approaches 5. If you look here and we try to apply our limit law, we can write this and from here we can see that we can approach this and we can calculate all of this, and simply we can evaluate the limit by direct substitution, right? Okay, direct substitution. So if f is a polynomial or rational function and a is in the domain of f, then okay, I think this is quite straightforward, right? Not really a big deal. Okay, actually in your textbook there are several things that are I think okay, I think I can make a more simple definition for you. Okay, so direct substitution, not a big deal. Let me write here how to evaluate the limit. Okay, how to evaluate the limit. I will make this exception not Lopital rule, not any derivative. Okay, so this is pure limit. Okay, pure limit. Okay, how to evaluate limit. So first, of course, direct, or you just plug in your x, right? Second, you need to evaluate the results. The third, is it in determinate form or 0/0 situation? So first you have limit and you try to evaluate. So you plug in a inside the functions, right? There will be some cases here. There will be some cases. So you will have at least 3 cases. At least 3. The first one, you will have some constant b divided by 0. And directly you will get, or you will notice that this will be your vertical asymptote. Okay. And then second, you get just b, and okay, done. And you'll be happy for the results. You'll be happy. And then the third case, when you have the f of a is having the 0/0. Okay. Now, when you have 0/0, there are at least several approaches before you are thinking about any of Lopital rule that you already learned before. Okay, probably. So there are 3. So first is you need to factorize the function. Okay, somehow. Okay. The second one is we call it's to conjugate or rationalize. The third one is to have some, if there is any trigonometry, you can try to look for the identity, and maybe you can simplify the function, and maybe you can have the results. And the last part is maybe just use approximation. Okay. So this is all that you can do aside from the Lopital rule. Actually, we will learn Lopital rule maybe after several chapters. Okay. Okay. So if you get something constant over 0, you have the vertical asymptote. If you have direct result, then you're done. You don't need to calculate more. And if you have 0 of 0, you need to think some way to get into the results. Okay, so you can factorize. If you can factorize, you can try to find rationalize if it's rational functions. And you can also use a trigonometric identity if it is trigonometric functions. Okay? Or you just use any approximations method. But I think you will also learn some approximations later on. Okay. All right. We still have time. Let me give you some example for the limit. Okay. I will just give you some sample. Let the function is equal this, and evaluate and the second one is this is A, this is B. Evaluate limit. Okay, two questions. I think not too difficult, right? I think it's very easy. So first we look here. If we look here, we can say that if we factor this function here, and we say that it's becoming x plus 3, and remember, when you are doing this, please make sure, okay, you understand the concept. Okay? It is somewhat similar. Seems that it is not a big deal, but it's actually a big deal. So let's say you have a function here f, and if you want to be careful, you need to name this a different function here, g, okay? Because this x plus 3 and this part, so x plus 3 and this is not the same in a function definition. Okay, that's something that you need to keep in mind. So basically, if you remember what we have done, okay, in a early class about piecewise definition, this is one of the example that you can apply. So it will be undefined when x equal 2, and it will be x plus 3 when x is not equal to. So you can say when it's not equal to, but limit is approaching 2, it's 5. Okay, need to be careful on that. Okay. Okay, any question first? to get my point here in this part? But if you already understand the concept, you know what the function is, how it does, and how the function behave. I think you can just write directly here if you want. That is okay. But if you're thinking the functions, how the process is, this is actually having a piecewise function here. It can be undefined when x equal 2, right? It can be x plus 3 when x is not equal to. Okay. Okay. Any question here? Oh, I'll just read. So the answer is DNA. Oh, that's for the previous one, right? Yeah, for the previous one. Okay. All right. The second one here, this is the. So whenever you see any square root at the bottom here, the instinct should be going for, okay, let's try to rationalize. Okay? And sometimes this method can be helpful. It can be helpful. So let's rationalize this by multiplying with the opposite sign of the denominator. Okay. So you will have it will become so x plus 5 minus 2. It should be x minus 4. Yeah, minus 4 minus, yeah, plus 1. So x plus 1. And this has x plus 1 and another x plus 5 plus 2. Sorry. And you get the idea here that this is square root of, or we can write this as limit x approaching -1 of square root of x plus 5 plus 2, which is 4. Okay. And of course, this example are 0/0 situation. If you look here, if you plug in -1 here, -1 here, this is 0/0. And this is also 0/0 when you plug in 2. So here and here, plus 4 plus 2, -6. It's 0, and this 0 also. Okay, so 0/0. Okay. What else we have? Okay. Let me go to some trigonometry. Okay, maybe let's make it a theta as a variable. Okay, we try to plug in here. It's 0/0, right? So we need to find a way to work this on. Okay. In my process, sometimes I'm using a function, a name of functions to make it a distinct. Okay. And when I'm trying to simplify, sometimes I try to make another functions that is alternative or simplified version of the functions. So I'm writing here. This is to make all the work still not mixed together. Okay, so So here I can simplify this, and it will be 1, 2 plus 2 cosine theta. So I will have this as a new function called g. Okay. So this is steps that need to be taken careful. Okay, you need to be careful here. Okay, if you forget why I'm writing here, so first is you have this identity, right? And then you can write this as this. Okay, another identity that usually we are using in calculus is the double angle. I hope you still remember this. And for cosine also. Okay. So if we have the function here, the back to the f function, the 1 minus cosine over 2 sine squared. So we'll have to, at least it will become undefined when x is equal 0, and it will be defined if this is not equal 0. And if we need to find the limit, then the limit will be okay. Okay, done. Okay, one thing to remember. You'll see the calculus is part of mathematics, and sometimes you need to focus on how to calculate the numbers, right? But actually, the concept in calculus is more important than you find like a number, or maybe you need to find the results of some like this limit case here. You need to find this 1/4. But this is not the most important in this case. Okay, the most important is you understand the process in between. Okay, it's not about just finding the right answer for just passing the course, or maybe getting good score in the exam. The learning is about how we understand the concept, the systems, the steps, how to proceed. Okay, like why we are doing this, like how we are going to move from this to this part. That's the most important. So sometimes in calculus, maybe like when you're writing an essay for the calculations, I will see the process, whether it is logically correct or no. If there is something missing there, although the answer is correct, I will still give some maybe not really a full point. Okay, not really a full point. And also, if you're not getting the right answer, but your process is correct, I will give you additional point. Okay, so I will see from both sides. Okay, how you answer it, what is the answer, and then all the process. Okay. So I will end the lecture in the one more slides. Okay, and probably that will be the theorem called the Squeeze Theorem. Okay, I think one of the students mentioned the Squeeze Theorem or Sandwich Theorem, some professors say. So Squeeze Theorem or theorem like that. Okay, let me give you the theorem first. Okay, let me give you the definitions and some restriction for this theorem. So this is y, this is x. Okay, and let's make maybe here, and this will be a number c, and this will be L. And I will draw 3 functions. Maybe this is like that. This is G. Okay. And this is F. Or maybe let's start F from the bottom. So this is H. And the last one is F. Let's say this is F. Okay, so all these 3 functions, they have a common intersection. Okay, common intersection, which is at x equals c. Okay, so they are all intersection. So they have intersection here. And they all the graph follows this f of x less equal g of x, okay, and less equal h of x. Okay, the theorem says that if limit, okay, as x approaching c for f of x, the lowest one, if it is equal L, okay, equal L here in the graph, right? And limit as x approaching c of h, the top one, okay, the highest one, is also equaling L. And from the restriction, we know that f of x less than equal g of x less than equal h of x. Then the conclusion will be the limit for the middle function for g will be also equal with L. Okay. Now this Squeeze theorem will be useful, okay, if you know all these 3 functions, and you know all the 3 functions will be in an intersection, okay, and you can use the Squeeze theorem, okay. And also this theorem can be used to prove this limit as x approaching 0 of sine x over x. Okay, we will prove this next week. Okay, so at least you have all of this. Okay. Okay. Any questions? Any questions? Mm-hmm. Any questions? If not, we will still have. I need some feedbacks from you guys because all of this will be on online lectures. So I will keep doing this. Maybe for a few, maybe the whole semester, we will be doing this. I hope you don't mind. Okay. Okay. Oh, okay. Okay. Please scan the QR code. Yeah. OMG. Okay. Okay. So from this small game here, I will compute all the leaderboard, like who are the winner. Of course, when you win the game, every time you win the game, I will mark that as an activity score. So I will give you some bonus point there. And also when you have like maybe you win like for 5 games or some games, hopefully I can give you something, okay, and I can give you when we have the final exam. So when we have a classroom, and I will give the gift for you. Okay, I think we can move on here. Let me stop the presentation. I will show you the QR code from the website directly. So stop presenting first. Okay. Okay, so you can go to the website directly, or you can scan the QR code. So you need to enter 23546250. Okay. Okay, we start the game. Okay, 3, 2, 1. Okay, let's start. Okay. Give me your name and student ID. I think your nickname also fine. Okay. Later I will just asking who the student is. Okay. If you want to. Okay. All right. Get ready. Okay. Who else? It's 40 now. I think we have 40. At least we need to have a 42. Okay, one more. One more. I think I can just start now. Okay, get ready. Okay, answer fast to get more points. And look the graph. And you have 45 seconds. I think this is not hard. You just need to be careful reading the text. That means each options mean true. Like option A, B, C, D true. Option B, option 2, A, C, D true. B, C, E true. A, D, F true. A, C, F true. And which one of them are correct? Three, two, one. Okay, time's up. All right. Yes, it's correct. Most of you are getting correct answer. Okay. And who are the fastest one? All right. Who? Oh, Bobby. Okay. Good. Fastest. All right. Next questions. Okay. Ready? Okay. Question 2. Let's start. 3, 2, 1. Okay. Okay, is that statement true or false? Okay, 15 seconds, 14, 13, 12. Okay. Right, 5, 4, 3, 2, 1. Okay, time's up. Oh, it's false. Do you know why? Because each of them are not exist as a limit. So we cannot do the limit law. Okay, that's the important thing. Okay, so you cannot do that. Okay, so you need to make sure each of the element in the functions they are exist. Okay, all right. And who are the fastest one? Whoa. Whoa, still Bobby. Okay, 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 okay. Right. Ready? Ready, ready? Okay, three. Question three. There is three questions. Okay, get ready. Three, two, one. Okay. Let's move on. Okay, is this true or false? No, the countdown is faster than before. 3, 2, 1. Okay, time's up. Okay, now it's correct. It's correct. No, it's true. It's true. Because you need to evaluate first each term, and then you can decide whether you can do it or not. Okay. All right. The last one is just a feedback. So after this, I need you to write some feedbacks. Oh, who are the first one? Oh, still Bobby. Okay. Congratulations. Congratulations. All right. All right. Good, good, good. Good game. Good game. Okay. Okay, need feedback from you guys. So if do you have any questions or any, not questions, maybe suggestions? Okay, you can write any suggestions like, how do you think our course so far, and what you need to, maybe the course is too easy, like, the early chapters is too easy. Maybe you can write something here, or maybe questions also fine. Like, yeah, you can, if there's no question, you can just, maybe no questions, or maybe no, or maybe, it's okay. Oh yeah, yeah. Later I will show you the QR code. Okay, but finish the feedbacks first. Okay, I will show you the QR code for the roll call. Okay, later. Okay. All right. Anything to write if you want, but let me give you the QR code first. Okay. Let me give you the QR code. Okay. Okay, some of you are asking about the example and exercise. I think exercise will be helpful for you. I'm planning to give you exercise and like an assignment, so you can exercise. Um, I think it will be around next week or next 2 weeks, because we are just entering the early chapters in the limit. Okay. A new function and number. Okay, I will tell you later. Can you give more example question? Okay, sure. Oh, okay. Yeah, I will try my best to give you the exercise. So first, you need to apply the Google account first, and I will assign the exercise through the Google Classroom. So it will be helpful, and I think you can also use the storage for your, for anything you want to put in. Like maybe you want to store some files regarding to your courses, any courses in the Google Drive, right? Yeah, I think some one of the question is, why was there a new function in number A and B? I think that is because the let me answer first. Okay, anyone need the roll call, the QR code? Okay, let me give you the idea first. Like for example, here I'm giving the name. It's just a name for the functions, because if you don't give this a name, okay, you will say that, okay, let's say fx is, this one is fx, right? The x squared plus x6 negative 6 divided by x minus 2 is the function f. And I have gx equal x plus 3. Let me write completely here. And can you say this is equal? Now this is, you need to be careful here, because we are talking about function, not just a regular equation. We are talking about functions. So that means this is not correct, right? So that's why, to be precise, I'm going down like step by step and making this g. But actually, if you're doing just regular calculations and you just write this, the last answer here as your answer 5, it's still correct. It's still correct. But I just want to show you what's the real process behind the functions here. Okay. And here you can say that, okay, I can simplify this and becomes x plus 3. This x plus 3 is not the same as the original function f. Okay, I hope that you can understand that. Okay, that's why I'm making like looks like I'm making a new function, but actually, it's a way of saying that there will be undefined sections when we going for x equal 2 for the f. That's why I'm having an x plus 3 here. Okay, there is two possible way here, right? Okay, that's why I'm using another function here to make our way clean and clear. Okay, but if you already understand and you want to directly answer and go here, the last part here, the limit is 5. But here, this is equation, the function equation, right? But if you write the limit, this is true. This is true. This is true. But the f is not equal to g. Okay? I hope you get my point, right? And that's why we need a limit to make this thing, to make this happen here. Okay? Okay, another question. We will have this small quiz in each class. I think no. Sometimes I'm just having a feedback, not really a quiz. Okay. Okay. Give more example with real numbers. Okay. Okay. All right. Giving, okay. Answered. Okay, I think there is no other question from you. I think we can finish the class now. So thank you again for joining. I will stop the recording.